This is Advanced Error Handling Techniques in LabVIEW, although the title has become a little bit of a misnomer, but you'll understand that a little bit more as we go on. Just going to introduce myself and Brian. I'm Christopher Relf. I'm the Chief Architect of VI Engineering. I'm a Certified LabVIEW Architect and a National Instruments LabVIEW Champion. This is Brian Gapske, who is a Test Software Integration Engineer at VI Engineering as well, Certified LabVIEW Developer, and hopefully soon to be a Certified Testing guy as well. Brian put a lot of work into the content that you'll see today. Not that I didn't do anything. So he's responsible for anything that's poor. A couple of quick slides on who VI Engineering is. We're a select alliance partner of National Instruments. We are not National Instruments, as a lot of people think we are. We build, our core is that we build ATE, but we also do a lot of work with companies to help them tie test back into production and design. A lot of the issues we see when people just want a turnkey test system is that they just say, this is what I wanted to do, and a company will provide it and walk away, whereas we try and understand what's actually going on in the company. We have a staff of scientists and engineers that work together with the company to make sure that they're testing it right. As opposed to a lot of the presentations you've already seen here, while we are really great and awesome and wonderful at using NI software and NI hardware, the whole product range, if you will, as I said, we're more about test and the esoteric world of test as well. So we love National Instruments products and we use them almost exclusively, but it's not like we don't like create tools that extend the LabVIEW environment. There's also already some great companies that do that, like National Instruments and JKI Soft, of course. So we're not going to play in that domain. You guys can do that. So real quick, what are we going to go through today? We are going to look at the current paradigm and use cases of what already exists in LabVIEW. We're going to look at a couple of ideas of extending that paradigm, and then I'm going to touch on how you guys can get involved, because we actually have a little bit of a unique situation here where a lot of the feedback that we're giving may be used in a future version of LabVIEW, but I'll talk about that in a sec. What this presentation won't cover, it's not a silver bullet, complete downloadable solution. Those people that were hoping to leave here with a CD with a whole bunch of code on it, that they just run the setup.exe and all of your error handling stuff would be extended and solved and all that sort of good things. I'm sorry, that's not going to happen. And we're also not going to talk about layers on top of the core. A little bit of history on this. The reason this presentation came about is because Dan Changrel, is Dan here? There's Dan up the back there. At the end of last year's NIWeek, raised a question about, how do you do good error handling? And I naively or stupidly put my hand up and said, you know what, I can do a presentation on that next year. Because I thought, people want to know, how do I write stuff to my error handling database? How do I write it to like the Windows error log, or those, how do I display it to my user effectively? I thought I could throw that together in an afternoon, that won't be a problem. And then, naively and stupidly, I put my hand up on Lava and said, hey, this is what I'm thinking of presenting, what do you think? And how many people here are Lava members? Alright, I like to see it. If you were following that thread, it exploded in 10 different directions of what people wanted me to present today. And they're all really good ideas, well, most of them are really good ideas. And I wanted to cover as much as possible, but every time I went down the path of these ideas, the weak point was the actual error core. So I made a decision that rather than talk about all those layers that you can build on top of what's native to LabVIEW, and put those into your applications, we really need to go back and look at the core of what's down at the lower level and address that and maybe throw in some ideas of how we're going to build that. Okay. So I'm going to really quickly step through, because it's a relatively advanced track, I'm going to step through the current paradigm, although the points I'm covering are important. They may look pretty benign, but we'll be coming back to them when we're looking at the new paradigms. So the native area cluster is a cluster, a standard cluster of 3 elements, although it has a nice round wire. I'm not going to tell you what we call it. It contains a Boolean, which has, of course, 2 values. There's either an error or there isn't an error. It has an error code, which is an integer. Up until recently, we had the range 5,000 to 9,999 to put our own errors in there. And it's just been recently expanded to include couple of gigaflops of errors there as well, which is fantastic. Thank you, Stephen, from National Insurance. And all the other ones are reserved for National Insurance to be able to assign. The third and last item in that cluster is a source, which is the string. Typical uses of that string is you throw in there where the error occurred, perhaps a call chain up to the top level application. So not only do you know where the lower level VI that had the issue was, but you can follow how it was called through the call chain. That's a description. One more rare use case, excuse my voice, I tell you what, every time they have an 80s tribute band at the NIWeek party, something, I don't know what happens. There are the append and the ERR tags, or the error tag, that you can put into the source string as well, and that's something that you can kind of wrap your own custom text in. The only real tangible benefit of using those tags is that a lot of information exists in the error cluster in that source string. When it gets to the general error handler, it's something that will filter out when it displays. It's important because we'll be looking at that a little later. Error data propagation is by value, just like most other data types in LabVIEW. Common use cases is obviously to pass and display errors. Error handling, so initiating shutdown, go into a safe state, ignore them, log them, whatever you want to do. So for example, if you have a state machine that has your own queued message handler there, and you've got 20 states on there, but then during the processing of those states, one of them has an error. You need to be able to make a decision on whether that error is important, what to do when that error occurs, possibly flush the state machine queue of all the other good things that you wanted your software to do, and then put the system into a safe state. Oops. And it's often used to force execution order when available. Most VIs that come from National Instruments have the error clusters on the error in on the bottom left and the error out on the bottom right, and of course have the error handling cases and all that sort of good things inside them as well. It's a really convenient way to chain stuff together. If you want to override LabVIEW's inherent need to be parallel, which is fantastic, and we've talked about that a lot this week. But if you don't want it to do that, and you don't want to use sequence structures, this is a great way to chain stuff together. Less common use cases. I've seen it used a lot, actually, as a data bus, because it is a standard error cluster and it's all the elements of the cluster are completely public. It's quite often and kind of more intermediate users will say, well, I passed that error cluster, and that's kind of one wire that goes through all of my stuff. And I hear that global variables are bad, and I don't want to really make a functional global, I don't want race conditions. Well, I'm just going to bundle in a little bit of text into that source string. Even though there's no error there, I know that means like 10 VIs down the road, that piece of data is still going to be in the source string. Oh, yeah, you haven't seen people do that?
No, it's just you.
I'm not saying it's a good thing. Don't get me wrong. I saw it actually take a
It has appeared in a number of cars coming in from customers.
There you go. Thank you, Stephen. I actually saw it take a company down once, but that's another story over a bit. Any other use cases that people use for the kind of the error cluster paradigm? That's pretty much covers them all, unless there's even more obscure things than using it as a data bus. It's like, I don't want another shift register on my diagram. I'll use the error cluster. We'll bundle them all in there. Pros. Most existing VIs use it, so it's a common methodology. It's intuitive because everyone has used it, so therefore it's intuitive, right? Simple, and it works. There's stuff built into LabVIEW itself that handles these sort of things. You don't have to write your own code. You just have to put your error into the error cluster. You can create custom errors or what have you, and then the general error handler will handle it all for you. Cons. It's flat. You can only have one error in there at a time. There's one status boolean, there's one code integer, and there's one source string. The structure is defined and unchangeable. Excuse me, you can. Unless you hack, but we'll talk about that a little later. Okay, so you have, as I said, one error boolean, one code integer, and one source string. You can only really have one type of error, because the codes are a linear progression or like an error lookup table. So you can't really tell the type from the code unless you have prior knowledge. Like error 7. File not found, thank you. Why did you know that error 7 was file not found? Because you don't find files very
all
often.
the time.
Happens all the time. It's just because you're experienced with the product. You know that 7 is file not found. What about error 132? Really? No one? I don't know what it is either because I've never seen it. I don't think I've seen 132. So you can't tell what the type of error is based on that code. And that's another reason why the source is there, to kind of filter that, to get that information out there in your lookup table. Wouldn't it be great if we could have maybe, rather than just an error 7, maybe have a group of file errors and a group of DAC errors? We already have it, and they're defined by where they are in the lookup table. But unless you know them, it's not particularly intuitive. The general error handler. It's important that I cover this because we kind of really screw around with it a little later. Common use cases, it's this, maybe you should have changed this. Oh, you can see that there. It's that little VI there that you pop down on your block diagram, and it's the be-all and end-all and handle all your errors for it. So it will display your errors, it warnings to the users, it provides you a basic mechanism to allow the users to make decisions on when an error occurs. How many times have people used this VI and then had complaints from a user that there was an issue, so they click stop?
Yeah.
Right? The whole thing goes down. You don't go into your safe state, you don't write the error to a database. I don't know how many times I've had the customer say, I had an error, and I click stop, and I'm like, okay, that's an issue, you just shut everything down. What was the error? I don't know, I clicked stop. I didn't have a chance in my software to log that error to file, because the general error handler didn't let me. Less common use cases. It can filter errors. Not a lot of people know that in each instance you put down in a diagram, you can change the way that which errors are shown and which errors are not. So you can filter errors. It's great. You can also override error descriptions on a case-by-case basis. Brian made me put this in here. It can produce unexpected results when placed in sub-VIs, so only do this sparingly and purposefully. So an example of that is, say you make a custom piece of hardware, or you have a reuse library that writes some data to disk, and you put down a general error handler in there because you want to be able to use it as its own unit. If you don't think about how then it's going to be used, you can end up really having negative effects further up the chain. So when someone uses your little reuse library, and in their architecture state machine or whatever, they have their own general error handler. They don't want they want to be able to handle the errors. They don't want the user to make the decisions down at the DAC driver or the write to file level. They want people to be able to use it up at the application. You happy now? Wouldn't it be cool if we could kind of brainstorm both on Lava and a VIE as well and came up with a bit of a list? It'd be great if we could have multiple errors existing concurrently, simultaneously. We don't want errors existing. Yes, Steve?
Before you jump further, there's one other advantage on the existing error cluster, and that is just it's fully interoperable with test and CDI. But both those products recognize the same sort of cluster, and there's a common error messaging system between other systems.
Right, that's a really important point. And not only those products, but all the modules you get from National Instruments and pretty much all the modules that anyone has ever developed use this paradigm. Right? So going away from it, obviously, that's a big pain point. And that I'll go over how to kind of alleviate that pain point a little bit in a moment. Wouldn't it be cool if we could have multiple errors exist concurrently? I'm just going to go through these relatively quickly. They're mostly self-explanatory. Have whatever data we wanted in the error structure, not be limited to those 3 static elements. Have a custom general error handler dialog for each error type. Define what we want to show to the user and give them different options based on the error type on what we should allow them to do. Do they want to ignore the error? Do they want to retry it? Retry might not be appropriate for all types of errors, but it might be appropriate for some types of errors. Continuous on. Or not show anything to the user. Control, limit, remove the user interaction completely. Filter out the errors based on the type of error. At the moment, we can't really do that. It'd be great if we could have a central method of handling, logging, escalating, other things. Anyone want to throw any ideas out on the floor while we're here? Yeah, Fred.
I would like to know how a sub-VI is handling its errors.
I'd like to know how a sub-VI is handling its errors.
Well, in some form of global suppression, if there's a nested follow general error handler in here, at the top of I want to say don't throw a dialogue, and I'll get around to a dialogue later when I get out of it.
That's a great idea. So just to paraphrase the example I said before, if you have nested calls down the general error handle, so your driver has one in there, some methodology of saying, I've already got one up here, so don't you do anything. Okay.
It'd be nice to have what they have in the .NET languages. You have an inner exception. So, for example, you get a visa error in one of your drivers, and you know that means, okay, this happened. So you write your own error, but you have the original error as inside that error. So you create
almost like a hierarchy of errors.
Exactly. You display to your user what you want him to see, but you log to disk the original error as well.
Right. Great. That's a great idea. Yes, sir.
Some sort of global switch, like the compilation variables, debug levels, so that you could say, process this level of errors, handling, more or less detail.
Okay. So I'm not trying to understand what you mean.
Well, like debug level.
Oh, okay. So
something
when
like that.
When you're at the build stage, have some sort of switch that, okay, I'm going into debug level and I want you to display every single error known to man when you get to the general error handler. But then when I do a build in deploy mode, I don't want those done because I'm going to log them somewhere else. Or the like. Great idea. Yeah.
Support. One line's out support for terse and verbose errors. So like as a developer,
Excellent idea.
as a user, you only want to show them simplified descriptions.
Right, and that ties a lot into Heiko's case there as well, where you kind of have a hierarchy of errors. You may want to have that lower level group of errors that, of course, the developer wants to know about. But when it gets to the general error handler, don't show that information. I'll look at that later or log it. Okay, got to move on. Unfortunately, we're not going to look at those last two ones. As I said, if you wanted that data stick as you're walking out with all the stuff built on top of the core, hopefully that's coming soon. Quick LabVIEW refresher. I'm going to talk real quickly about classes and objects because we do touch on this pretty heavily when I talk about the two implementations that we have here. Just a quick show of hands of people that not necessarily use OO stuff but understand the basic premises behind it. Almost everyone. All right. Great. That makes me happy. Well, then I'm going to go through it even more quickly. So your methods allow you a method of acting on your objects, because objects are encapsulated. So one of the great foundations of OO programming is that those objects have encapsulated data, and methods give you a way to get access to that data and write that data. Inheritance, parent-child relationships. So we have the ability, the age-old example of the cell phone. I love this one where you have a cell phone, and hopefully all cell phones in a class have a microphone and an earpiece and buttons to press so you can dial and they, make calls. And then you may have different types of cell phones, so like a GSM cell phone or a CDMA cell phone that inherit those properties and methods from the parent class in that they all have buttons and make calls and the like. But they have different attributes and methods of their own. And one of the beautiful things about OO is that you can override parent methods. So if there is a particular method up in the parent that is kind of the generic case or the general case, and then you are inside a child object, and you want to have a specific method for that child that overrides the parent method, you can do that. Or if you don't have that method there, then use the parent one. I just said that. X controls can't be in classes, but they can be friends of the class. Brand new in LabVIEW 2009, makes me very happy. Take a class. No pun intended. If you don't know OO, the National Instruments, the old group course, is absolutely fantastic, one of their better courses. Even if you don't have the time to go and do the class, buy the course kit, step through it. I see that, not very good. I see that a lot of stuff that NI has come out with now, especially with LabVIEW, I see so many opportunities for those sort of things to migrate over to OO paradigms. It's an extremely powerful thing to use. There is a couple of pain points and aha moments at the start, but once you've got those, it's plain sailing. It's really quite beautiful. Okay, now I'm finished with the current paradigm. Now I'm going to talk about a couple of ideas that have been floated. This first one I'm calling the RAP native error cluster in OO. Yes, that's right. The primary motivation for this paradigm is that we wanted to have multiple errors. Secondary motivation is that we wanted to expand the information that we could have in the error without having to just plug everything into the source and build on ourselves. We designed this in-house, bit of a brainstorming session. What would we like if we could change the world? And we all can change the world, as Jim Green says, one VI at a time. In this paradigm, we have native OO objects that get passed around. So on your block diagram, the old error cluster wire, the brown error cluster wire, is replaced now with an error object. I don't really know what to call it. That'll do for now. I'll go back one. All of the error data that you would normally have in the native error cluster plus more stuff is inside of that object. The errors data type, so I had an error data type, which is your error, and an errors data type, which is essentially a list of errors. So the errors data type is an object of error objects. I can understand how this would be confusing to people that don't know OO, which is why you go and do a plot. More than one error can exist simultaneously. Errors can be prioritized. Using this method, we need to replace the general error handler, the one that's down in like LabVIEW, VI-lib, ErrorLib. That needs to be changed to be able to handle this sort of paradigm. It has its own general error handler, so you can use them in parallel, but that is really kind of a bad way to do so. Pros of using this paradigm, and I will show an example in a tick, so hopefully it'll make more sense. Error data is expanded, but still mostly strictly defined. Within the model that we came up with real quick, we have custom attributes is one of the elements that's inside of error, and you can manually handle those. They're nice, but you have to do a lot of work to actually make them valuable. You can have as many simultaneous errors as you like. You can convert from the old native error cluster to this error object and back again, which is obviously really important because we already said everything in LabVIEW and, as Stephen said, outside of LabVIEW uses that error type. The error wire is overt, and the reason this is a really important point is that you don't have to worry about nasty existing VIs wiping out the new data error format. I mentioned earlier about a company being sunk because they shoved a whole bunch of stuff in the source as a data bus. If you put stuff in that source, you can't really be guaranteed, like that source and the code and the Boolean are public. It's public data. Once that error cluster goes into a sub-VI, you have lost control of it. That sub-VI can do whatever it likes with it and then pass whatever it wants out. Now, hopefully, if an error does exist, if it's been programmed right, that sub-VI is going to have a big error case around it, and it won't execute what it's supposed to do. There are, of course, edge cases where you do need to do that, but it will continue and pass that error through. And it's the same with this. The reason we did this kind of as an object on the diagram is that you can't wire this object wire into an old error cluster. It'll break. Okay, so hopefully when people write VIs to work with this paradigm, they understand the paradigm and don't wipe stuff out. Otherwise, it can happen unintentionally. Cons. It doesn't support abstraction of custom error types. You need to create and manage modules to work with the custom attributes that I mentioned before, especially knowing which attributes are compatible with each error type. It's a lot of work. Well, it's not a lot of work, but it's a lot to keep track of. So that's absolutely a con with this paradigm. I had a con here that you needed a custom front panel control because, as I said, essentially we're passing around an object, and when you put an object down in your front panel to wire into connect pane, it is of the object symbol, right? And then Brian came up with the idea of, well, we'll just use an X control and make it a method of a member of the class, and we'll be able to access all the data of the class. You can't put X controls in classes. But they can be friends. So you can have an X control. Again, brand new in LabVIEW 2009. An X control can be a friend of a class. So you can now have, let me step back a little bit. The native error cluster, where you can just put the cluster down on the front panel and you run the VI, you can see the error data in there. With this paradigm, until the X controls could be friended to classes before that, all you saw was this is an object, so you can actually see the data that was in it, or interact with it. This paradigm requires some LabVIEW knowledge to develop custom error classes, but you don't need any of that knowledge to use the paradigm. You need to understand LabVIEW to create the classes, but you don't need to understand inheritance. So get learned. Okay, I'm going to do a quick demo. Where hopefully all of your furrowed brows will relax and look a little more. Okay. So what I've got here, as I said, we really have two classes. We have the error class and the errors class. I'm just going to open up that error class. Errors class is really just a collection of errors. Yeah, that makes sense. Okay. Here's my example. Oops. So I've got a native error cluster on my front panel here, which currently has an error 7 file not found for any case. And what we need to do is convert that native into the new object type. So ignore the DDs here. That's telling me to deep dive and open those ones up because I think it might find them interesting. Pretty simple stuff, really. When we convert the native error cluster into the object class, we're basically taking the information that's in it. This is this VI is a member of the class, so it has access to the data and adding a timestamp to it. Then when it comes outside of that, here, if you have a look at the context help window up there on the top right-hand side, you can see all the information that is in this new error type. As I said, one of the cons of this is that it's static. There's more information in there, and what information in there isn't really that important. It's just something we came up with, but it's static. You can't change it. So you can see in there, as I said, time, string, classification, priority, all that. You can put in there whatever you like if you're designing one of these paradigms. Then we've got the standard, well, not the standard, but a replacement for the error display, which looks similar to the general error handler. And please excuse the lack of icons here. Where we take out the interesting information from the object. So this Y here is still of the object type and not of the native error class. We take out interesting stuff like summary, message, diagnostic information, and it's basically just a modal dialog that will pop up. We have VI here that writes stuff to file. Don't know how interesting that is, but basically checks if the files exist. If it doesn't, creates one, adds a header, then gets all the goodness out of there and writes a line to file. It also has a second error out, I don't know if you saw there. We still, of course, pass the original error out as a duplicate of we pass out the duplicate of the original error. There's a second error out, which is if we did have any issues while we're trying to log, like in the file, didn't write properly. I have a merger of errors here, clear errors, and then I just flag it. Let's just go ahead and run that. Oh, I don't have any information there. Well, I have some. So, as I said, this looks very similar to the general error handler. But it's just there's more stuff in there, and we can define that stuff as we go. If I click ignore, the error gets closed out, and there's no log. If I say OK, continue, that error was important to me. It goes to the logging step here. It creates a little text file not found for any case. And if you fill out the attributes of each of those properties, they would be shown in the file. So if I run that again, you continue. Have a second file in this. So that's the error class. Above that is the errors class. Yes, ma'am. Sure.
Are those the support VIs for handling the error?
These VIs here are VIs that we obviously wrote because we've got the nice, cool little VI engineering line on the bottom there. And that's what I said earlier is that these replace the general error handler stuff.
So each of them perform a certain function for managing your errors.
Each of those perform a certain function for managing the error. Right. And you could, we've got the simple write-to-text file. If you wanted a write-to-database file or whatever, you would add those. But as I said, we're not going to the level above the paradigm in this presentation. Okay. So the errors class, if we, I might just, I like the example, look at why. The situation where I have 3 errors coming in here, all still in the native error cluster. Remember how I said the object is just shown as that on the front panel? This is probably where you'd replace that with an X control. As was mentioned earlier, I think Joel mentioned it. You could show or hide as much information about the error as you wanted in that X control. Just for purposes of illustration, I am building an array of those errors, adding them to this errors object type. We have a different error handler up here, which can display multiple errors. A different write file one. I might just put on that. I'm sorry, hang on a minute. Just dancing.
Sorry.
Sure.
So it's just a collection, it's just an array of the errors.
I'll show that in just a second. Steve?
I do have a question. You said it's a different write file, and I'm like, it's not an override write file?
It's not an override write file, although that would certainly work. It's just it is. Let me show you the wire type. So basically, what you have in there is your errors class and just an error boolean, right? So that would certainly work. The way that we've implemented it here for the write file is that it just iterates over the errors that are inside the list. Can. I need to show that from below right. Let's link up about that afterwards, because that's certainly a way that you could do it. For this implementation, we chose to just get each of the errors out and iterate over them, but that's an excellent idea. So, where was it? Yeah, so the data type of the wire, because we're not using any sort of inheritance in this example, basically the errors type is just a collection of error types, plus an additional boolean which tells you whether there's an error or not. Okay? And that is useful because when you go into a case where you say, okay, I've got to handle all my errors, the first thing you do is say, are there any errors? And if there aren't, you don't have to do anything. So that's a weakness of this paradigm, and certainly something that could be extended, but I'll get onto that in a moment. So when I ran that example there, run it again. Yeah, again, custom general error handler shows a number of errors. Has a different functionality, very straightforward. So it's very similar to the one at the error level. Populates the table and gives you the ability to be able to continue, ignore, timeout, whatever you need to do.
Do you have the ability to clear individual errors?
That's an excellent thing that should be on the roadmap. We thought about that when we were implementing this, where we would be able to put like checkboxes next to each of the errors, and even further than that, it would be great if we could, on an error type basis, maybe give people different options to not just, as opposed to ignore and continue, but ignore and log, or ignore and don't log, and then you would need on top of that the topology of when do I allow people to do that. If I'm in debug mode, I let people do it. If I'm not in debug mode, I don't let them do it, or I can limit the capabilities of it. And look, we could, no one's got any flights out today. We could sit here all day and actually knock this out if you like. Okay, so that is the example of the error cluster inside the object. I'm going to step on to the next one, and this is one primary motivation for this guy. This is to wrap the OO error inside the native error cluster. So this is kind of the opposite. And what we wanted to do here was extend the information that was inside the error. It was created by Stephen Mercer from NIWeek. He's back there, so you know it's good. I was going to put a nice little photo of you up here. There's Steve. Put your hand up, Stephen. Stephen Mercer. So basically what we're doing here is that we're putting the OO object inside that source string of the native error cluster. I said earlier, it's just a standard cluster. You can put whatever the hell you like in there. Sorry, put whatever the heck you like in there. We'll edit that out a little later. And this is, as Stephen brought up, the reason it was designed this way is because it needs to coexist with the current native error cluster framework. For National Instruments to make some great big decision that they were going to switch over to a completely different structure for passing errors around would not only have a huge impact on all the products that they release, not just LabVIEW, but Testan, CVI, all that sort of good thing, but all their customers as well. We would have to see the extra overhead step of converting between the two error types all the time. And that overhead may not be, well, first of all, it's going to be difficult to implement, and second of all, we may not want that overhead. Inheritance model is used for user-defined new child error classes, and I'll explain that a little further in a moment. And this is a replacement for the native general error handler. The new general error handler for this type of paradigm that Stephen wrote also handles the old type of native error cluster as well. So if the information or all the extra information isn't in the cluster when it comes in, the error handler can see that and then just act on it as though it's the old type and switches back to the old mode, which is cool. Pros. You can have whatever data you like in the wire. The example we showed before, there's more stuff there. And, there's a variant attribute-based custom attribute, variant attribute-based custom attribute field, which is actually also a variant, which is neat. I mean, that means you can put whatever you like in there, but you have to manage it, whereas this one is a whole lot easier to work with. You can create custom classes to represent your error data, and it has all the goodness you have come to expect from OO. It's extendable. You can add a new error class for each new class of error. Protected, you expose only the public methods that you need to. It's modular, so you can reuse error classes between projects where appropriate. We've got there you define classes based on functional areas, or you can define classes based on functional areas if it makes sense to. What information they hold, how or what they display, it's really up to you. It takes a little more forethought at the start to really design something like this, but you can really benefit from that. And it's dynamic. Using dynamic dispatch, you write only the methods that you need to. And I'll demonstrate that in a sec. Cons, it replaces the general error handler, so the whole error lib in your user lib. I'm not sure whether that's a pro or a con or a nothing. The reason I put in the con slide is because it could be challenging to distribute and track. If you're using this paradigm and you create your own child error types, and then you give it to someone who hasn't installed this, I'm not sure what would happen. I assume that, well, actually, you kind of see what would happen. Yes?
You create a package of it and you use the package manager.
You create a package of it and you use the package manager. That's a good answer. I'm happy with that answer. Currently, it only operates in a flat model, one error at a time, just like the native error cluster implementation. It needs VIs that use the native error cluster to behave. I mentioned it earlier, some VIs don't pass errors through. Some of them mangle the source text. What you'll see is that we're embedding that object into the source text, and if there is a VI that screws around with that, then you're going to lose your object. It's going to be corrupt. It also requires, again, I don't know if this is pro or con, but it requires LabVIEW knowledge to develop custom error classes. You don't need LabVIEW knowledge to use this. You do need to understand LabVIEW and inheritance as well to create your custom error types. So get learning. Is there a class? Is there a classy class? There is a class to learn about class. As I said, the National Instruments OO course is one of their really good. I mean, they're all really good ones, but it's one of their better, really good ones. Quick demo. And this is something that Stephen actually posted to Lava months ago, I think. And it had a high number of downloads, but not very many comments. So I really wanted to show it here today just to show you the power of it, and hopefully we can revive that thread a little bit. So as I said, we're using an OO model here with inheritance in it. So at the higher level, at the parent level, you have that top folder there where I've jammed everything into the class's error engine. And that's kind of like your general error handler, and if a custom one doesn't exist, that one will still handle all of your standard errors, plus it will handle all of the methods that are common, all of the parent methods that are common that aren't overridden. And then you have your user-defined errors. Now I'm going to open up the demo. It's probably better to show it this way. In this demonstration, we've actually got 3 different types of error. We've got the standard one in your block diagram here. We've got a VI here that checks if an IP address format is valid, and I'm hoping that that one isn't. Because if it is, then there's no point of it being in this demonstration. And then we've got another VI down here which checks my F drive disk space. I don't have an F drive, so hopefully I'll have an issue out of that one as well. And then we're, again, just for the purposes of displaying this, I'm building those into an array. And if we look at the data type of that wire, it is just a 1D array of your standard error, your status, source, and excuse me, and your code. So this, you can see there's a little blip up there. I just added that to remind me that that's not the standard simple error handler. Basically, if we run this, the first thing, once we get over here, we've got our 3 errors in this. Maybe I should probe that. Anyway, we've got our 3 errors in this 1D array here. And the first one is the standard error that's on the block diagram there, and it looks like the standard general error handler message. If I go and continue, then that general error handler is going to process the next one, which looks very different because we've got an image there as well. If I click continue, I have another different one. This should look familiar because this is the same as the class that was in the last example. So this error handler is, some component is being overridden based on whatever the child type of error or what the type of error is that's going into it. In fact, what I'll do is, let's open up this guy. So this left-hand side of the code here is the thing that's actually checking whether my IP address is valid or not. And then what we've got is we've got a parent, as I said, we've got a parent error class, which is the one that is of the error and takes care of all the stuff that's common to all of the errors. And then we have a picture class, which is the child class. And that picture class has a VI that where you can add in your picture. You can see down here Stephen's made an image that he's hopefully telling us if there is a network issue. And then we have a VI which is adding that. So if we look at this VI here, which is part of the parent class, pretty standard stuff. All we're doing is throwing on the status and the code itself. The source is the same. And then if we look at this VI here, which is adding the picture, looks pretty standard, but this is the picture of that picture error type child class that's been adding on there through the joys of dynamic dispatch. Then what we do is this cool little VI here, which I love opening. We check if there was an error, and if there was, basically we take that whole error, we flatten it to a string, and we shove it in the source. Right, so our object, our error object continues to persist along the native error cluster. So I'm going to show you that. I'm going to run that example again, but this time I'm going to probe that 1D array. So we'll run that, and I'll click continue 3 times. The first one is just the error cluster that was on the diagram there. The second one, what's going on there? This is basically that flattened string representation of the object. In fact, if you scroll down there, you get to start seeing these Ys. They're the pixel representation of white. So that picture is inside that source there, and then hopefully some light bulb will come on here. We're actually flattening all of that information down into a string and using the native error cluster as a data bus to pass the information around.
Except that you're actually passing error information around. Thank you. So it's not just random data.
Right, we're passing error information around. That's a really good point. When I said earlier, I
commit
said
that same error again.
right, but
Still opportunity for that.
when I mentioned earlier, I said it's not necessarily a bad thing.
Chris, can you show the block diagram and check IP?
This one?
Right.
Sure.
The one that's sitting there behind that.
Yep. So we've got the picture error class, and I'll take you into those in just a moment. These ones here where we're setting the error, like the status in the code, and the source is their methods of the parent class, the parent error class, and the set picture is a method of the specific child class.
Can you show the methods for the parent?
Sure. So this one?
Off of the project.
Oh, the project? I'd rather not. Because there's several levels of stuff actually going on there, and I think once we get it on all back onto Lava, then we'll be able to discuss how they all those classes interact, because it's not really just one class. There's several levels of the change. I can, but I'd rather not.
Okay.
I mean,
we can table that.
Yeah, we'll table it. It's definitely stuff we need to talk about, and we'll get on Lava and throw it around there. I just don't want to lose people at this point. Okay.
Could this in essence be expanded to handle multiple errors?
Absolutely.
By use of a custom error code that says I have multiple errors, and then you just flatten all your errors into your string data.
There are several ways that it could be done, and I'm actually going to talk about that right towards the end, although I'm kind of running out of time. But it's a great idea, and it's kind of one of the first things people ask when they see this paradigm. It's like, okay, it's great, I can put whatever I like in there, but it still doesn't solve the issue of multiple errors. But we'll get to that. Okay, so what's really happening here? You saw the probe that I had on this wire here, which showed you that all that object information had been stuffed into the source. But where it really gets cool, when we drill down into the core, so this is not the native error cluster core. This is a specific core that was developed for this paradigm. Basically what we do is we take in that error cluster, which is like the old native error cluster with all the stuff in there. And then we do an opposite pretty much, where we get the stuff out. Well, we look first if it had that object tag. I meant to mention that. When we put the stuff in there, we prepend that with angle brackets OBJ to say that this is an object, just for us to keep track of it later. If we don't find that, then it must be a normal error cluster, so we'll be able to pass that through and build it into that error type. If we do find it, all we do is we use that unflattened from string to get our object back out, and then we pass it out the indicator there. Okay, so now we have our object has been rebuilt, or not rebuilt, but we see it again. It's in its original form. We do some general error filtering. What am I going to do with this sort of stuff here, which is also in the general error handler. But the really interesting part is this guy over here. This is where we display the error. And the reason this is interesting is because this is in VI that the children of the class, the child classes can override. And this is where it happens. You notice when I ran it the first time, I had 3 completely different dialogues come up depending on the type of the error. That's because those, if they're one of the custom data types, one of the custom error types, I've got a VI that brings that information up, formatted in the way I like. And it kind of adds to your point, Heiko, when you were saying, maybe I want to show them certain things, maybe I don't want to show them certain things. This is kind of a similar thing, but on a different level, that I can do it on a error type by error type. Like with Stephen's example there, where he wanted to show an image of, hey, your network card's not plugged in, or there's a network error. I might want to do that for my type of error. You can put in whatever you like there and use this to override those. So if we have a quick look at the, kind of a shame I step all the way back up here. We look at these custom children. There's really not that much in there. We have the set picture method that we showed before, which is just really to get the picture into the object. I'll set the picture in the object. Then you have the subpanel, and inside the subpanel can be whatever you like. What we're doing here is we're taking in that parent object, and then we're making it the more specific class of the picture, so we can get the information out right there and we're displaying in the picture.
In the morning when you're designing these, make sure you turn on automatic error handling.
Wow. So if we go into the other one here real quick. This example where I check my F drive, if there's an error, I'm going to use again those parent methods to set the same parent methods to set the status and the code, and then I use the stuff that I showed in the previous example where I then am able to move it into the verbose error type for the previous example, stuff it all into the source, and then when it comes down to the point where it's going to display my source, I have a completely different VI, which I can put whatever I like in there. Same thing, taking the object, more specific class to the child class type, rip the stuff out, and put it on the front panel. That's kind of a whirlwind tour of those two designs. And we're almost out of time, so this is kind of my last slide. This is a work in progress. It's not. I'm not up here saying this is what we use all the time, and you should use it too, and it's awesome, and it does everything that you want. Because we've already seen from a lot of questions here, one of the paradigms doesn't do multiple errors. Can we expand it to that? The other paradigm has static types of errors. Can we change that? I'm not up here speaking as an authority telling you that this is what you need to do. It's a community-based work in progress as well. Are these the right ideas? I've only presented you with two, and they're just a couple that we came up with. And Stephen came up with one, we came up with another one. Surely there are more out there. Quick show of hands, people that use programming languages other than LabVIEW. So like C++, Visual Basic, whatever. You guys are really important to this process because you're working in another framework that already has its own way of doing these things. And what we'd love to see is you guys put your hand up and say, hey, I use VB, and I really like how in VB it does it this way, because then we can bring that into LabVIEW. And someone else will say, I really like how you do it in C++, and then we can bring that in and build something that's even stronger than all those by just cherry-picking all the really good parts of them. Should we push one of these? How about a combination? As we again, you brought it up. The OO one looks really good, but can it be extended to do multiple ones? Sure it can, if it makes sense to do that, which I think it does. But we need to get together and talk about that. I already mentioned that one. Can this succeed without native LabVIEW support? And this is a question that was kind of thrown around in lab for a while. The answer is yes, but not very well. I honestly think that this is, thank you. I honestly think that this is something that we certainly need to get investment from NI on. I believe that the possibility of replacing the native error cluster and also the native error cluster general error handler in a near future version of LabVIEW is a very real one. NI never tells you before they're going to release something, and occasionally they'll say something like, it wouldn't be unreasonable to believe that blah, 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 blah. I don't work for NI, so I've got no idea what NI is going to do. And I don't represent that I know what NI is going to do. But I think that based on the community interaction that we've had on this topic, that it's certainly a pain point for people. We've seen a lot of really innovative designs come out of the community of how we can make it less of a pain point and really expand it. So it's certainly a candidate, I think, to really expand the LabVIEW world. This is my last slide, and I'm out of time, as that lady just told me. So rather than take general questions now, what we're going to do is recording the presentation today. We're going to put the slides and the VIs that I showed you today up on Lava sometime in the next week or so. I really stress that you guys can be a really big part of driving this, and if you It's like voting. If you don't vote, you can't complain about who you get. So please get in there and vote with your feet. And that's all I got.